Hello and welcome to Mech Zone. In the previous lecture, we were studying about the classification of gears based upon the type of gearing, and we have learned that there are two types, that is the internal and the external gearing. In the external gearing, the directions of rotation were opposite, and in the internal gearing, the direction of rotation were same. And we also saw that out of the two bodies, the smaller body is made as the pinion or the driver, and the larger body is made as the driven or the gear. And why the smaller body was made as the driver? Because it can rotate at higher angular velocity omega, and the number of teeth corresponding to the smaller body, that is the pinion, were less. So since power is equals to torque into omega, and omega is very high, and since omega is large for the pinion, so for the same power T required would be less. Agar power same rakhni hai, then T required would be less, and that is why the smaller bodies are made as pinions. Now the next topic that we have to start with is with the gear terminology. Gear terminology. Okay, so in the gear terminology, I will now draw the diagram of the various terminology of the gear structure and the various terminologies used. Okay, so we have the different circles, and the down circle, this is which is lying at the lowermost part, is called as the root or the dedendum circle, and on the above portion of the root or the dedendum circle we are having the clearance circle. Then we have the pitch circle, and at last we have the addendum circle. And this we have already discussed, that this is the face width, this is the top land, this is called as the face. Okay, this is called as the face. And very important is to remember the order of the circles. So we first have the dedendum circle, then clearance circle, then pitch circle, then base circle. Okay, and this is the face width. The distance between here to here is called as the tooth thickness, and the distance between this tooth and the beginning of the next tooth is called as the circular pitch. Okay, and the gap between these two tooths is called as tooth space. This is called as tooth space. Okay, and this space is called as clearance. This space is called as clearance, whereas this entire distance is called as working depth, and working depth is nothing but addendum plus dedendum minus the clearance. So working depth is addendum plus dedendum minus the clearance. So we have to remember this also. And this was the clearance circle. All the circles have been marked, and this is actually called as the addendum. This space is called as addendum. Okay, and this entire space is called as total depth. This is called as total depth. The space between the two tooths is called as the tooth space. This the gap between the faces of a particular tooth is called as the tooth thickness, whereas the gap between the face of the first tooth to the face of the next tooth is called as the circular pitch. So one thing we have to remember here is that the various order of these circles. And this was the face, and the down portion is called as the flank. Once face is above surface is called as the face, whereas the lower portion is called as the flank. Okay, so above the pitch circle we are having the face, and below the pitch circle we are having the flank portion. So flank portion is actually which is lying below the pitch circle, and above the pitch circle we are having the face. So this is the diagram of the tooth and the various circles I have discussed now. Now we will discuss about the various circles, that is the pitch circle. Now to discuss, the pitch circle is an imaginary circle in the gear where the pure rolling is observed when the mating gears are transmitting the power. So it is actually a imaginary type of circle where pure rolling is observed when the mating gears are transmitting power. Okay, and being an imaginary circle, it cannot be the physical characteristic of the circle, but being the most important circle, it is one of the most, not one of the most, but it is the most important circle, and it is the biggest specification of a given circle. And the size of any gear is specified by the dia of pitch circle. Why it is very important? Now you must have come to know that the diameter of any pitch, any gear is actually specified by the diameter of the pitch circle. Okay, now we will see, say this is gear like O1 center, the gear O2 with another center, and this is the gear like this, another gear is like this. So if I draw a line, actually I should draw it a bit straighter. Yes, this is the line. So this is gear number 1, it is rotating like omega 1 with velocity. This is gear, and the lower one is the pinion, and we know that the pinion is actually a driver and the gear is actually a follower. So the line of this point, the point, this is called as the pitch point. Okay, this point is called as the pitch point, which is the contact point between the pitch circles of the two gears. तो जहां पर दो gears के pitch circles मिलते हैं, that point is called as the pitch point. Okay, so when it is moving in the clockwise sense, the other would be moving in the anti-clockwise sense if they are in external gearing, and this is actually the line of action. This is called as the line of action, and the line of action always passes through the pitch point, always passes through pitch point. It always passes through the pitch point. And if we draw a line such that it is tangent to both the circles, so this would be called as common tangent at the pitch point. This is called as common tangent at pitch point. So this is called as common tangent at the pitch point. And the point of contact and pitch point are actually two different points. Point of contact is the point between any two surfaces, whereas the pitch point is actually the contact point between the pitch circles. Okay, pitch circles जिस पॉइंट पर मूव करेंगे that would be ये इस तरीके से होगा, कुछ देखिए ऐसे घूमेगा, तो एक गियर ऐसे जाएगा, दूसरा गियर ऐसे जाएगा, and the contact point between the pitch circles would be called as the pitch point. This angle is phi, and this phi is called as the pressure angle. This angle is called as the pressure angle. So if we resolve F, it will have F cos phi in this direction, and this point is called as P. P is actually the pitch point. Okay, so this is common tangent at the point of contact, and this is the line of action, and it is always passing through the pitch point. Okay, and this common tangent is actually a fixed line. It will always be a fixed line. Next we come to another important terminology that is called as circular pitch. Circular pitch. Circular pitch is represented by PC, and if D is the diameter of the pitch circle, D is actually the dia of pitch circle, and we have learned that this actually diameter or the pitch circle is the main in deciding the size of the gear. So if D is the diameter of the pitch circle such that the circumference would be equals to pi D, and if number of teeths are T. See, anything which has teeth on its surface cannot be a gear, क्योंकि हमारे में भी दांत हैं, इंसान में भी दांत है, तो क्या हम इंसान को गियर कह देंगे? बिल्कुल नहीं कहेंगे. तो उसके लिए भी एक स्पेसिफिकेशन होता है, टीथ तो हो, लेकिन उसके साथ साथ भी कुछ कंडीशंस हैं जो जब फॉलो होंगी तभी उसको एक टीथ बोला, मतलब तभी उस बॉडी को गियर बोला जाएगा. तो सर्कुलर पिच is actually defined as pi d upon T. Circular pitch is pi d upon T. And for two mating gears, अगर दो mating gears होते हैं like this, mating is being like this, so एक के teeth दूसरे के teeth में interlocking करते हैं, तो उसका circular pitch of 1 is equal to the circular pitch of 2. And this condition is actually holding for the two mating gears. Okay, so तो यहां से क्या हो जाएगा, सर्कुलर पिच ऑफ 1 इज इक्वल टू सर्कुलर पिच ऑफ 2, मतलब पाई d1 अपॉन t1 इज इक्वल टू पाई d2 अपॉन t2. पाई पाई गेट्स कैंसल्ड आउट, सो d1 अपॉन t1 is equals to d2 upon t2. These are very very important formulas and we definitely have to remember them. Okay, the next terminology, very important, it is called as the module. It is represented by small m, and small m is equals to capital D by T, such that this is in millimeters, and this is also defined for mating gears. Mating gears का मॉड्यूल जो हो जाता है वो हो जाता है बराबर, the mating gears for the two, sorry, the module for the two mating gears is actually equal. And if we talk about the capital R is actually the radius of the bigger gear. This would be equals to small m into capital T by 2, and the radius of the smaller gear would be equal to m into small t by 2, where capital T is the number of teeth on the gear and small t is the number of teeth on the pinion. The next terminology that we will discuss is diametral pitch. So m is equals to d by t. So in this we can also write the circular pitch is equals to pi into m. तो यहाँ पर pi into m का भी फॉर्मूला हम लोग यूज कर सकते हैं, where m is the module. और diametral pitch क्या होती है? It is defined pd is equals to t upon diameter, but this diameter should be in inches. It should be in inches, such that pc, that is circular pitch, into diametral pitch is equals to pi into d by t multiplies by t by d, क्योंकि सर्कुलर पिच होती है पाई डी बाई टी और डायमेट्रल पिच थी t by d, so this would come out to be pi. तो ये भी क्वेश्चन भर भर के पूछा गया है कि pc आपको दिया हुआ है और pd आपको निकालना है, तो we will use this formula. Now for example, if this was one teeth, and this is say point Q, and this is the line of action, this is actually the point of contact, and this is actually line, this line is called as the common normal at Q, or simply called as the line of action, and the angle phi that we have defined is called as the pressure angle. Angle phi was called as the pressure angle, and the general value lies between 20 to 22 degree, but the maximum value can be extended up to 25 degrees. We cannot increase the value of the pressure angle beyond 25 degrees. And what was phi? Phi was actually the angle between the line of action and the common tangent at the point of at the pitch point. So pitch point पे जो common tangent है और जो line of action है उसके बीच का angle would be called as the pressure angle. और जो हमारा tooth space था minus tooth thickness, this is simply called as backlash. This is called as backlash, and the backlash is mainly provided to avoid any jamming of the teeth due to thermal expansion. अब हमारे जब ये जो gears हैं जब working में होंगे, then definitely heat would be generated, और heat क्योंकि generate हो जाएगी तो वहां पर possibility है कि thermal expansion हो जाए, और अगर thermal expansion हो गया तो उसके कारण jamming भी हो सकती है क्योंकि teeth का size थोड़ा बहुत बढ़ घट जाएगा. तो jamming होने के कारण हमारा जो गियर है वो डिस्ट्रॉय हो सकता है, इसीलिए हम लोग क्या दे देते हैं उसमें एक बैकलैश दे देते हैं. बैकलैश इज एक्चुअली द डिफरेंस बिटवीन द टूथ स्पेस एंड द टूथ थिकनेस. सो और हमने ये भी बताया था द पोर्शन विच इज अबव द पिच सरफेस वो जाता है फेस, एंड विच इज बिलो द पिच सरफेस इज कॉल्ड एज द फ्लैंक. तो backlash is mainly provided so as to avoid any jamming of the teeth. Okay, And there is one note point, an important note point we will tell you, that when the two bodies are in pure rolling, then the tangential velocity and tangential acceleration are equal. You have to remember this point. When the two bodies are in pure rolling, then tangential velocity and tangential acceleration are equal. And we have already discussed about what is tangential acceleration and what is radial acceleration. Radial or centripetal acceleration, we have discussed that it is always directed along the radius and towards the center, whereas the tangential acceleration is always perpendicular to the radial component of acceleration, and it is in the sense of alpha, or it is in the sense of omega. Now with this we come to the end of the terminology portion. Now we shall be starting with the law of gearing. Now we will start with the important topic, that is law of gearing. Okay. And in the law of gearing we will first draw a diagram. These two bodies are two gears such that it is rotating with omega 1 and this is rotating with omega 2. This body is having the center O2 and this body is having a center O1. This point, let us say it as Q. Okay, this point is Q. Okay, now what we have done is we have drawn a line from this point at O1 and from this point and this line is actually drawn such that from O1 we have dropped a perpendicular and the perpendicular is O1M. Okay, and here we have, by extending this line backwards, this line has been drawn perpendicular and it becomes O2N. V1 and V2 would be the linear velocities of the bodies 1 and 2 and would be simply R into omega formula लगाएंगे तो V2 is equal to O2Q, that is O2Q, this distance, into omega 2, and O1Q, that is this distance, O1Q is this distance into omega 1. Please mind this line has been drawn by mistake. This is one line which is connecting O1 and O2 and P point is lying here. And this is actually representing F, that is the line of action. This is actually representing the line of action. This angle is called as beta. This entire angle is alpha. And we know that O1 and O2 are fixed points. O1 and O2 are actually fixed points. So the components of velocity are same along the line of action. That is, if I draw a diagram, this point P, this is O1M, this is O2N, these two angles would be equal. So we will see that V1 cos alpha is equals to V2 cos beta. Okay, we have actually resolved these velocities and hence they would be equal because the components are same along the line of action. So O1Q into omega 1 into cos alpha. The value of cos alpha from this diagram would be O1M upon O1Q base upon hypotenuse. So this would be O1M upon O1Q, and this is equals to, the value of V2 was O2Q into omega 2 multiplied by cos beta. In this triangle we will see cos beta, it is equal to O2N upon O2Q, that is base upon hypotenuse, that is O2N upon O2Q, and we know that O1Q is actually equals to O2Q in this diagram, although it may not look to be, but it is actually equal. So sorry, that is not equal, sorry, I am very sorry. O1Q and O2Q are not equal. This and this will be cancelled out. So what we will obtain, omega 1 upon omega 2 is equals to O2N upon O1M. This is equals to O2P upon O1P. This is equals to Pn upon Pm. The triangles O1 PM is similar to triangle O2PN, and from there we are getting these relations. Okay, for these body to be gears, omega 1 upon omega 2 should be a constant quantity. तो अगर इन बॉडी को gears होना है तो ओमेगा 1 अपॉन ओमेगा 2 शुड बी 0. तो सिर्फ टीथ होने से ही कोई बॉडी गेयर नहीं बन जाती. ओमेगा 1 अपॉन ओमेगा 2 शुड ऑल्सो बी 0. बट लेकिन हमारा O1 एंड O2 दिए हुए हैं, दे आर फिक्स्ड पॉइंट्स. तो P शुड ऑल्सो बिकम फिक्स्ड point in order to maintain O2P upon O1P to be constant. तो P भी क्या बन गया हमारा? P also becomes the fixed point. तो लॉ ऑफ गेयरिंग को कैसे स्टेट करेंगे? The line of action must pass through the fixed point which is known as the pitch point on the line joining the centers of rotation of the gears. This line is joining the center of rotation of the gears and P is lying on this line. So for the body to be gears, the line of action must pass through the pitch point. यही है हमारा short and सबसे effective statement कि for the body to be gear, the line of action must always pass through the pitch point, and the line of action is actually common normal at Q. The line of action is also a common normal at Q. Okay, this line of action is common normal at Q point. So the mating profiles are designed in such a way that the law of gearing is always satisfied. Law of gearing हमेशा हमारा satisfied होना चाहिए, और इसी को मद्देनजर रखते हुए हम लोग अपनी gearing profiles को डिजाइन करते हैं. और जो हमारी conjugate profile होती है, conjugate profile, it is actually a profile which is satisfying the law of gearing. ये law of gearing को हमारा satisfy करता है. तो that is why we prefer the conjugate profile. And there are two profiles like involute profile and the second one is cycloidal profile. And these two profiles are actually conjugate profiles. That means they are following or they are satisfying the law of gearing. Now if we look at the velocity of sliding, and the velocity of sliding can be written as phi sliding is actually v1 sine alpha minus v2 sine beta. This was actually the velocity of sliding. So if we will solve this, I am simply writing down the expression. I am not writing down the individual components because expression is more important. So we will obtain it as omega 1 plus omega 2 into QP. QP क्या था? QP was the distance between the point of contact and pitch point. P and Q तो हमारा point of contact था, P हमारा pitch point था. तो ये हो जाएगा हमारा velocity of sliding, that is omega 1 plus omega 2 into the distance between the point of contact and the pitch point. ठीक है, तो ऐसा हो सकता है कि हमारा point of contact और pitch point एक जगह पर दोनों coincide कर जाएं. तो अगर वो coincide करेंगे तो PQ would be equal to 0, and at that point the velocity of sliding would be 0, and since sliding is not taking place, hence pure rolling would be observed at that point. Pure rolling is observed when the sliding velocity is 0 and sliding occurs at the point of contact. Okay, now we will discuss about the involute profile. We will discuss about the involute profile, and the involute profile is by nature it is conjugate. By nature it is conjugate, so it is following the law of gearing. And how will be defined? How will we define the involute profile? It is defined as the locus of a point on a. It is defined as the locus of a point on a line which rolls without slipping on a fixed circle. So if this is a circle, okay, and this is a tangent, say, so it is actually the locus of the point on a line which rolls without slipping on a fixed circle. So from this point say this point is A1, from this point this is A2, say from this point it is A3, and if we have a different curve then B1, B2, B3, say this is the center of the gear, this is corresponding to A, this is corresponding to B. So these actually two profiles are involute profile. ठीक है, and A1, A2, A3 are very closely spaced. These are very closely spaced elements, and this is actually the fixed circle, or also called as base circle. Okay, fixed circle or the base circle. And और यहाँ पर हम देखेंगे कि ये जो हमारे हैं जो हमारा नॉर्मल है which is drawn at any point on the involute curve will be tangent to its base circle. कोई भी अगर कर्व पे हम एक नॉर्मल बनाते हैं then that line would automatically become a tangent to its base circle. और position of the base circle किसी involute gear में कहाँ होती है? मान लीजिए ये हमारा टूथ है, ठीक है, तो 3 सर्किल होते हैं, 1, 2, 3. तो सबसे नीचे वाला जो हमारा सर्किल होता है दिस इज कॉल्ड एज दी बेस सर्किल. उसके ऊपर पिच सर्किल, फिर होता है अडेंडम सर्किल. तो बेस सर्किल के ऊपर जितना पोर्शन होगा वो इन्वोल्यूट होता है, और बेस सर्किल के नीचे जितना पोर्शन हो जाएगा वो नॉन इन्वोल्यूट हो जाएगा. ठीक है, नीचे का पोर्शन बेस सर्किल से नॉन इन्वोल्यूट, मतलब ये वाले जो पोर्शंस है दीज आर द नॉन इन्वोल्यूट पोर्शंस, वेयर एज द पोर्शंस व्हिच आर लाइंग अबव द बेस सर्किल दे वुड बी कॉल्ड एज द इन्वोल्यूट पोर्शंस. ठीक है, एंड इन द एक्सटर्नल गियरिंग द बेस सर्किल कैन नेवर कम ऑन द डिडेंडम. कभी भी बेस सर्किल डिडेंडम पे नहीं आ सकता. और अगर हम बेस सर्किल का रेडियस डिक्रीज करेंगे देन करस्पॉन्डिंगली वी वुड इंक्रीज द प्रेशर एंगल. लेकिन प्रेशर एंगल को बढ़ाने पर भी एक लिमिटेशन है कि द मैक्सिमम वैल्यू ऑफ दिस प्रेशर एंगल कैन बी ओनली 25 डिग्रीज. ओके, तो जनरली ये देखा गया है कि नॉन इन्वोल्यूट पोर्शन को कभी भी परमानेंटली हम एलिमिनेट नहीं कर सकते. हाँ, रिड्यूस कर सकते हैं टू अ सर्टेन लेवल, बट वी कैन नेवर एलिमिनेट दी non-involute portion. Okay, now we will look at the analysis of the involute gears. तो यहां पर देखिए ये हमारा एक गियर है, that is the bigger wheel, and the pinion is given here such that the gear is rotating at an angular velocity omega 1. और गियर का जो भी नोटेशन होगा वो हम कैपिटल लेटर से करेंगे और पिनियन का हमेशा हम लोग स्मॉल लेटर से करेंगे. तो यहां पर जो हमारा AG मतलब अडेंडम सर्किल ऑफ द गियर, AP मतलब अडेंडम सर्किल ऑफ द पिनियन. तो ये पिनियन का था, ये गियर का था. कैपिटल R इज द रेडियस ऑफ द गियर. मैंने आपको बता दिया M इंटू कैपिटल T/2 हो जाता है, और RA इज द अडेंडम रेडियस ऑफ द गियर, वेयर स्मॉल RA इज द अडेंडम रेडियस ऑफ द पिनियन हो जाएगा. ठीक है, और ये जो पोर्शन है K से लेके L तक है, एक्चुअली यहां पर एंगेजमेंट स्टार्ट हुआ और यहां पर एंगेजमेंट एंड हो गया. ये थी आपकी कॉमन नॉर्मल और कॉमन टेंजेंट, और कॉमन टेंजेंट और लाइन ऑफ एक्शन के बीच का जो एंगल है दैट वुड बी द प्रेशर एंगल. तो इसी के करस्पॉन्डिंग हमारा जो एंगेजमेंट है दोनों के बीच में K से शुरू होगा और L पे जाकर खत्म होगा. तो जो लाइन ऑफ एक्शन की बात करें तो लाइन ऑफ एक्शन इट इज एक्चुअली पासिंग थ्रू द पिच पॉइंट एंड इट इज टेंजेंट टू बोथ द बेस सर्कल्स. ये हमारा बेस सर्किल है गियर का, ये हमारा बेस सर्किल हो गया पिनियन का. तो ये जो हमारी लाइन ऑफ एक्शन है इट इज एक्चुअली टेंजेंट टू बोथ द बेस सर्कल्स. ये देखिए एक बेस सर्किल ये है और एक बेस सर्किल ये था. तो ये जो हमारी लाइन ऑफ एक्शन इट इज एक्चुअली टेंजेंट टू बोथ द सर्कल्स. तो यहां पर हम देख रहे हैं कि K से लेके L तक इनफाइनाइट नंबर ऑफ पॉइंट्स हैं जहां पर हमारा एंगेजमेंट पॉसिबल है. तो पॉइंट ऑफ कॉन्टैक्ट जो होगा वो तो आपका कंटिन्यूअसली चेंज करेगा, बट द लाइन ऑफ एक्शन इज नॉट चेंजिंग. यहां पर आपकी लाइन ऑफ एक्शन कभी भी चेंज नहीं होगी, और इसी के चलते जो आपका फाई दैट इज प्रेशर एंगल होगा वो हो जाएगा आपका कांस्टेंट। तो यहां पर ये सबसे बड़ा एडवांटेज है इन्वोल्यूट गियर्स में कि प्रेशर एंगल हमेशा कांस्टेंट रहेगा, बिकॉज द पॉइंट ऑफ कॉन्टैक्ट इज चेंजिंग बट द लाइन ऑफ एक्शन इज नॉट चेंजिंग। और यहां पर हमने ये देखा कि जो पॉइंट ऑफ कॉन्टैक्ट है इट इज एक्चुअली ट्रेवलिंग अलोंग द लाइन ऑफ एक्शन। तो लोकस ऑफ क्यू पॉइंट जो था वहां पे, द लोकस ऑफ क्यू पॉइंट वुड बी अ स्ट्रेट लाइन। ये भी बहुत इंपॉर्टेंट क्वेश्चन है जो हमसे बहुत सारे एग्जामिनेशंस में पूछा गया है कि व्हाट वुड बी द लोकस ऑफ द पॉइंट क्यू। ठीक है, तो द टाइम इंटरवल इन विच द क्यू इज ट्रैवलिंग फ्रॉम द स्टार्ट पॉइंट टू द एंड पॉइंट ऑफ द एंगेजमेंट, उस टाइम को हम कहेंगे कॉन्टैक्ट पीरियड, उसको हम कहेंगे कॉन्टैक्ट पीरियड। और जो K से लेके पूरा L तक का हमारा पाथ था उसको हम कहेंगे पाथ ऑफ कॉन्टैक्ट, उसको हम लोग कह देंगे पाथ ऑफ कॉन्टैक्ट। और ये जो पाथ ऑफ कॉन्टैक्ट है इट विल बी मेड अप ऑफ टू डिस्टिंक्ट एलिमेंट्स, एक होगा पाथ ऑफ अप्रोच, एक होगा पाथ ऑफ रिसेस। अप्रोच मतलब जब दोनों गियर्स आपस में एक दूसरे को अप्रोच करेंगे, और रिसेस का मतलब जब ये दोनों एक दूसरे से दूर जाएंगे। तो path of contact is actually made up of two things, path of approach and path of recess. So with this we come to the end of this lecture. In the next lecture we shall be continuing from here onwards. So I hope कि आपको हमारे lectures पसंद आ रहे होंगे। तो हमारे चैनल पे अपना valuable feedback हमें देते रहिए। हमारे चैनल के बारे में अपने friends और अपने colleagues को भी बताइए ताकि उन्हें भी benefit मिल सके, because everything is absolutely free on this channel। सारा study material, सारे quality video lectures for SSC, JEE, GATE, ES एंड पब्लिक सेक्टर्स पूरे के पूरे अवेलेबल है, और हमने कोई भी लेक्चर स्किप नहीं किया है। हाउएवर अगर कोई एक पर्टिकुलर टॉपिक छूट जाता है देन यू कैन टेल अस ऑन द चैनल एंड वी शैल बी अपलोडिंग दैट सून। सो विद दिस वी कम टू द एंड। थैंक यू सो मच।